Hello and welcome to Csci45 Computer Architecture and Organization. My name is Brian Baker. I'll be your instructor for this semester. And hopefully it'll be a fun course online. It's kind of difficult to teach computer architecture online. There's not a whole lot of practical things we can do online. But we'll hopefully make up for that with some interactive textbook stuff in Zybooks. And I'll talk about that in a second. The purpose of this course is really to look at that sort of layer from where you write code in C, C++, Java, whatever, your higher level language, and the hardware. How does it get to machine code that can be run on hardware? Every single processor in the world has its own proprietary machine code that it needs that matches the instructions, the actual circuitry pathways in that processor. And so really, the instruction set architecture is the interface to a particular processor. Each one is different, each one is unique. I understand that for the vast majority of people, you think Intel are the only processors in the world. They're not. Embedded machines, embedded computers, all sorts of different types of machines use different software. And in fact, the Intel hardware is not always ideal for a particular thing. And so if you've had Csci40 with me, we talked a little bit about, that process of going through to assembly code and having assembly code get converted to machine code. That was foreshadowing for this class. Basically, we are, trying to kind of look at that process and actually even be able to write our own assembly code. Chances are you will never have to write your own assembly code outside of this class. In this class, you will write assembly code, but you won't need to. You can write at a higher level language and use a compiler to get the assembly that you need. But anyway, speaking of assembly code, I'm switching this class. I used to teach this in MIPS. So MIPS is an instruction set architecture, an ISA, for any processor that uses a MIPS core. And so essentially, if you're making your own silicon, you can pay MIPS to get this, to be able to use a license for their particular instruction set. And that means that you have to actually develop all those different circuit pathways for all of the instructions that MIPS will understand. I am switching it to ARM. And part of the reason for that is that MIPS is becoming less and less popular over time. Now, does this matter? No. MIPS is the one that's traditionally taught because it has a very simple assembly code. ARM is just a little bit older. They had to make a bunch of concessions in the early days, and so that's always kind of been a weird thing. But in the newer versions, there's sort of a subset of the ARM instruction set that looks a lot like MIPS. It's a lot easier to use. And so this textbook came out that was like, oh yeah, hey, by the way, we're the same authors. It's like the former president of Stanford wrote your textbook. But like, we can actually do this in ARM for these newer versions, and it'll be almost as simple. And this is the actual assembly code that'll be used for ARM processors. So ARM processors are the processors that you probably have in your smartphone right now, especially if it's Apple or Samsung. It's definitely an ARM processor. For most other manufacturers, they're ARM processors. If you have a newer Mac laptop, those are ARM processors, the Apple Silicon that they make themselves. They license the cores from ARM so they can develop those themselves, but using that ARM instruction set. Raspberry Pi, for the most part, those are ARM processors. And so if you ever wanted to play with assembly code with a Raspberry Pi, ARM processors, that would be a great lab if we taught this class in person. But regardless, I switched to ARM just so it would be a little bit more practical. But again, it doesn't really matter. What matters is more the concepts, understanding how software gets from one stage to the other, because you probably will not need to actually write an assembly code. To that end, because it's an online class, I wanted to have some interaction, so I'm using a Zybook for this class. I use that for some of my online-only classes. So there is a cost associated with it. It's like $72 for the subscription. And you can get to it. Don't go to zybooks.com and set up an account. I think I have warnings for that all over the Canvas course. Just click on your first assignment. When it pulls you in, you can subscribe there, and then you're sure that you're subscribing to the correct our particular sections course in Zybooks, so that when you do assignments, you actually get credit for them. So the nice thing about a Zybook is that instead of just reading about how Oh, this assembly will move data from, someplace in memory to a register. Or even, this is what a register is. You can actually see illustrated diagrams of where the data is flowing, what the registers are, what they represent, all that sort of stuff. I'm going into stuff that you won't get for another couple weeks, but point being, it's a much more interactive experience, so I think it's well worth it. And so yeah, we're using the Zybook for this week. You will need the Zybook. There's no way to get around it. So yeah, as far as this first week, we're really looking at basics. It's going to be a lot about sort of the engineering ideas behind computer architecture. What does it mean to get performance through prediction, right? How does that work? Just general engineering concepts of ways to improve or perform things, but not necessarily looking specifically at the machine. And then we'll get into some of the actual machine itself, really basic parts to kind of understand how your system is actually set up and works together. But looking at sort of hardware from I would say not a detailed view. It's going to feel detailed to you because we have yet to get to here are the actual parts of the CPU itself and the registers and the ALU and all that sort of stuff. So, but it is a much more cursory overview of computer hardware. So it's really just computer basics this week. Should be good. All the stages to get from source code to machine code, parts of the computer, stuff like that. Each week you're going to have a video like this, or maybe a video where I'm actually on a computer demoing something for you to kind of help you with those week's concepts, at least as much as possible. I've got a couple young kids, so sometimes video production can be difficult. So hopefully it'll always be up on Tuesday every week, but if it takes a couple days, forgive me. This is also, I think this is actually my second time teaching the course, but the first time was a while ago, and it was sort of as a favor. This is my first time teaching this course the way that I want to do it for computer science here at Fresno City College. So yeah, it might be a little rough at times, as we're trying to develop materials, but hopefully you find it helpful just in an understanding thing. Like at the end of the day, it's just my job as a computer programmer is going to be writing source code in a high level language. But if I understand sort of what's happening underneath, how it gets its way to hardware, what it's doing in hardware, it can be helpful in sort of informing how you write your code. Just because you get a bigger sense of you get a better sense of the picture. When Apple suddenly decides that they're writing their own silicone, and you're making apps for iPhones, you're going to understand why that's an issue. You're going to oh wait, or I guess technically it would be the laptops that made the switch from Intel. By the way, Intel's instruction architecture set is called X86, and it would be great to learn, but it's proprietary, and it is a different type of processor than ARM, which is why a lot of people are moving to ARM. Or I shouldn't say a lot of people who make very specific devices. This is a side note. It's going to be covered later weeks. I shouldn't talk about it, but regardless, X86, the Intel processors, and by the way, also the AMD processors, but Intel does all the work. They develop everything and then they license it to AMD because the US government told them they need to because of the antitrust thing. So it's really Intel and then ARM and MIPS and a few other people who make processors. But Intel's processors are what we call CISC processors. They're complex instruction set computers. That means they have lots of pathways. There's lots of instructions. It's a very complex instruction set, right? And that means you can get anything done much faster. Intel is great for that. You want that. But you also have a lot of circuitry that you're pumping electricity through that you're not using at any given moment because it's got so many different pathways for its complex instruction set, which means they use a lot of power. And that's great even Apple's Mac Pros at this point still use Intel Xeon processors because it's plugged into a wall and we're assuming you don't care how much power you use. Nobody thinks about how much power a computer takes until, I don't know, you go mining for Bitcoin or something. But if you're on a phone, your battery life is going to be miserable. You don't want an Intel processor in your phone, right? You want something from Motorola, which, you know, they make great processors that are very easy. They use RISC processors, reduced instruction set computers. MIPS, ARM, both of these are examples of RISC computers, reduced instruction set. And the idea is that we have fewer pathways. That means you might have to run like a pathway followed by another pathway to get something done, but you've got fewer pathways that you're having to power without actually using them. So they're a little bit better on battery life. Anyway, mile high overview and a complete simplification. But the idea is that's why we're not learning the Intel one, in part because also Intel is very proprietary and there's not a whole lot of materials available for their instruction set architecture. Also, as the name would imply, it's more complex. It's a complex instruction set computer. So the assembly code is a lot more complex as well. Anyway, all that being said, there's also going to be some optional resource videos. You can check them out if you want to. They just give a little bit of context and flavor, but really it's getting into that interactive Zybook. There'll be some quizzes and stuff like that, discussions as we go on through the class. For this week, your assignment 1 is really just the first 4 subsections of chapter 1. And so that should be hopefully fairly easy. Like I said, it's all about basics, just computing stuff. There is a quiz number 1 that's really just about sort of some of those design concepts, the engineering concepts that are brought up in those first 4 sections. And then your discussion is just to introduce yourselves to each other, to get to know each other. Believe it or not, your relationships with other people in the class matter a lot more for your success in this class than your relationship with me. I'm always available for you. Like, feel free to send me a message. But if you know you've got other people that you can communicate with in the class, that helps a ton. So anyway, that being said, this is Computer Architecture Online. Hopefully it's a good class and you enjoy it. Like I said, expect it to be a little bit rough since this is the first semester teaching this class, the way that we're going to want to teach it in the future. I'll probably make revisions next time, add additional materials, etc. But hopefully you enjoy it. So that being said, have a great week and I will see you online.